All right, absolute value. Again, I think this is going to be some review for you. Not the first time you've seen this, but we're going to have to remind ourselves of quite a lot. There's a bit that we have to sort of work out here. But absolute value, you got to remember what absolute value means before we can start solving anything, and we'll review that. And so that's the deal. We want to be able to solve absolute value equations by the time we're done. There's your standards. Absolute value. What is meant by absolute value? What does absolute value tell you?
The distance from 0 on the number.
Right. The distance from 0 on the number line. Doesn't matter if you're going to the right from 0 on the number line or the left from 0 on the number line.
No.
Is the distance going to change because you're going left to right? No. Okay? And the cars are supposed to drive, but we lose the animation here. That's okay. Right? So, in other words, the absolute value is distance. How many of you guys live negative 2 miles from the school?
So it's impossible to be negative.
Right. It's impossible to be a negative. Absolute value is always positive. Okay? So there's your some of your definitions. And again, guys, vocabulary. You should be studying your vocabulary. You should not miss any points on the non-calculator part of your test. Especially the vocabulary part. All you got to do is memorize some definitions. Okay? But absolute value is the number's distance from 0 on the number line. Since it's distance, we're never going to be able to be negative. Never. Okay? Absolute value of 2 is positive 2. Absolute value of negative 2 is positive 2. That's 2 is 2 from 0. Okay? Now, if we're going to solve an equation with absolute value in it, okay, we have to remember that. We have to remember that no matter what you take, if you take the absolute value of it, it's always going to be positive. In other words, when we solve an equation, we're looking for solutions. Solutions are numbers that we can plug into the variable that make the statement true. What can I put in for x that makes that statement true? Dylan, what's one number? 6. So x can be 6. Is there anything else that we can plug in for x that makes that statement true? Hunter, what do you think? Yeah, we can plug in negative 6. Because the absolute value of negative 6 is 6. And so that's true. And therein lies the trick with absolute value equations. Okay? If I know the absolute value of something has to equal a number, then there are 2 possible solutions that I can plug in there. I can plug in the positive version of that number or the negative version of that number and still get a true statement. Okay? And so what you'll hear me talk about, and what we'll do a lot in here today, is we're going to split. Once we have the absolute value of something equals to a number, we're going to split into 2 different equations and solve those down. Okay? And that's why. Because absolute value is always going to be positive. You can plug in a positive or a negative number there and still get a positive. Okay? So, let's try this. Right? So instead of now the absolute value of x is equal to 6, the absolute value of negative 4x is equal to 24. Right? And so now the solutions, we've got to find out what we can plug in for x to make this thing true. Well, to help, instead of just guessing and plugging in numbers, to help us do that, we know that, because of what we just took a look at, we know that negative 4x can be replaced with what number and to make this thing true?
4x.
No.
What?
That's not what I was asking.
Oh.
Negative 4x can be replaced by what? What can I put in front of, inside these absolute value bars instead of negative 4x to make this true? Not 12, 24. I can pull this negative 4x out and stick a 24 in there and make the statement true, right? In other words, negative 4x can be 24. Or, what else can I pull out? What else can I put in for this negative 4x? Negative 24. So negative 4x can also be negative 24. So we're going to split this guy into two equations and solve these down. Divide by negative 4. And so x is negative 6. Divide by negative 4. So x is 6.
Couldn't you have just done that from the beginning?
Yeah, I got it. I did it.
We mean just done that from the beginning.
Like,
Okay, absolute value of c plus 9 equals 17. What that means is that c plus 9 can be positive 17 and make that statement true. C plus 9 can also be negative 17 and make that statement true. In other words, we're going to take that and split it and say c plus 9 equals 17 and c plus 9 equals negative 17. Okay, and subtract 9. So c equals 8. Or c equals negative 26. Okay?
I got C equals 8.
All right, let's see if this makes any more sense by doing that guy. Okay? Absolute value of 2x plus 1 equals 13. Right? We're going to split it. Split it. 2x plus 1 equals 13. And 2x plus 1 equal to negative 13. Okay? 2x plus 1 can be 13, or 2x plus 1 can be negative 13. So we're going to set that equal to 13 and negative 13. All right, then we subtract 1, subtract 1.
yeah, you have mixed them up. Isn't it 12?
Oh,
Yeah, you mix
whoops.
it up. It's 12.
Going a little
See,
fast.
see, that's where I got the 6 and the negative 6. It's like,
And then negative.
Okay, there you go. Let's try that guy. All right, we're going to set this equal to 39. Set this equal to negative 39. Divide both by 3. And so, again, another situation where that's pretty much what happens. But, as we just saw, not always. Okay, so we need to get in the habit of splitting up our two equations and solving them separately. Okay? All right. Questions? Do we feel confident enough? Try that one.
Because that's the answer.
oh yeah,
X plus 5 equals 17. X plus 5 equals negative 17. Subtract 5, subtract 5. And there you go. Okay? Good? Okay, we got another one. Try that. Okay, we're going to take 4x minus 2 and set it equal to 18, and then take 4x minus 2 and set it equal to negative 18. Add 2, add 2. Divide by 4. Add 2, add 2. Sticking. Divide by 4. So x is negative 4 and x is 5. Okay? Questions? Issues? Concerns? Okay? Solving multi-step absolute value equations. Okay? And it's a lot like solving any other equation. And I'm going to offer up a way to kind of do this to try to keep it making sense until you get really comfortable solving these. Right? But the deal is we got to undo everything that's not inside the absolute value bars. any numbers outside the absolute value bars need to go away. Okay? Because we don't know what number we can plug inside those absolute value bars to make that statement true until the absolute value bars are all by themselves. Okay? And then we're going to split. Once the absolute value bars are all by themselves, then we're going to split into our negative and positive numbers and solve our two equations. Okay? So, here's kind of what I mean. Here's what I suggest you do until you get really, really comfortable, right? We're going to do this the exact same way we would if instead of x plus 2, absolute value of x plus 2 being here, it was just one giant x. So what I'm going to do is I'm going to create a parallel equation. I'm just going to take the absolute value out of it and replace it with an x. Okay? So that on the right-hand side, what would you do first to solve that equation? Yeah, you would add 1 to both sides, right? So 3x would equal 9. Guess what? It's going to be the exact same thing on the left-hand side. I'm going to add 1 first. Nope. Just one step at a time, guys. Just one step at a time. Right? So on the right-hand side, I had to add 1 first. That means on the left-hand side, I'm going to add 1 first. Okay? Now, on the right-hand side, what would you do next?
Minus 2?
No.
Minus 3?
Divide by 3.
Yeah, that's right. Ah, x equals 3.
Okay? Guess what? On the left-hand side, you're going to divide by 3.
Wait, so could we do it either?
Now, the guy on the right-hand side you're done with, right? If you were solving this equation, you'd be finished. So we don't really need that anymore, so I'm going to kind of cross it out. This is the actual problem we want to solve. Now we're down to what would you put inside the absolute value bars to make that statement true? Instead of the x plus 2, what could you put inside those absolute value bars to make this statement true? 3 or negative 3. So we're going to split into our two equations. Subtract the 2 and x is going to be 1. Subtract the 2 here and x is going to be negative 5. Those are your two solutions.
Oh, I got the first one right, but I did it. So
Okay? Let's try this guy. Okay? See how you do, and then we'll go from there. Here we go. First thing you're going to do, you have to get the absolute value bars by themselves. Okay? The difference between this problem and that problem, because we just split number 7 immediately and set that equal to 18 and negative 18, right? The difference is there were no numbers outside the bars there. But there are numbers outside the bars here. So we have to approach this a different way. Ashley, the first thing we're going to do. Subtract 2. Okay. That's why I'm trying to get you guys to replace the absolute value bars with an x. Okay? Over here to the right, and I'm just going to take this, take it out of the equation for a second, and replace it with just an x. This right-hand side has absolutely nothing to do with the actual solution to the problem. Nothing. Okay? All it's designed to do is to help you see what you should do first. Because now, when we look on the right-hand side, actually, the first thing you're going to do is what? Right. And since I'm going to subtract 3 first on the right-hand side, that means I'm going to subtract 3 first on the left-hand side. The right-hand side is just supposed to tell you what you need to do. Leave the absolute value bars in on the left-hand side. Okay. On the right-hand side is our aid. Then what would you do to solve the right-hand side? Right, divide by 2. Which means on the left-hand side, I'm going to divide by 2. Okay? Now this equation that I've gotten down to right here looks a whole lot like that guy. And so now I'm going to do what I did for number 7. I'm going to split it. X plus 9. You update your iPad and it stops working.
I know, right?
Okay? Split it into equal negative 2 and equal to positive 2. Subtract 9 and you get negative 7. Subtract 9 and you get negative 11. Okay? We got it? We can try. Yes, question. Okay, try this guy and see what you get. What's the trick? We'll give you a nudge first. What's the trick here?
Common denominator.
Don't get common denominators. What are you going to do? Clear the fractions. Right. So all of you guys are trying to clear your fractions. Finally. Thank you. And you're doing it correctly. You're picking out the right least common denominator. Multiply through by 9. But the trick is you got to multiply everything by 9, including the absolute value bars. So we get 9, absolute value of x. 9 times 1 is 9, divided by 3 is 9 times 4 is 36. 36 divided by 9 is 4. Okay, now why? Because remember what we said, guys? We're going to create a right-hand side equation that looks just like our original equation, only we're going to take the absolute value bars out. If we had x plus 1/3 equals 4/9, and you decide to clear your fractions, you would have to multiply everything through by 9, including this x. Oh, this is making me so mad. And so you get 9x equals 3, or 9x plus 3 equals 4. Yeah.
Alright, well I put the 9 inside of the absolute value bars and still got the same answer. Is that okay? Is that what you're supposed to like practically do?
All right. So from here, hopefully by now we see we got to subtract 3 from both sides. And then divide by 9. Oop, I keep doing that. And then divide by 9. So the absolute value of x is equal to 1/9. If you were to split that, then you would get x equals 1/9 and x equals negative 1/9. Okay? Okay, try that guy. Okay? So to isolate the bars, we got to subtract 3. Then divide by 2. Now that the bars are by themselves, we know what's allowed to go inside the bars to make this statement true. We know that x minus 3 can be 4. Oh. Or x minus 3 can be negative 4. Add 3 and x is 7. Add 3 and x is negative 1. Oh, shoot. I was going to call on Ashley for that. Sorry, Ashley. Okay? Try that one. All right, here we go. Subtract 5.
I mess up somewhere. I don't know where.
Okay, divide by negative 3. Okay, now the absolute now the bars are by themselves. We can split.
I do that step
Subtract 8 here, and you get negative 3.
Oh, so it's
No.
7?
Subtract 8 here, and you get negative 13. Okay?
Still.
Have to be